We're given a test statistic. Z is 1.42. That just means like they gathered some data, and depending on what their hypothesis was, and for this one they needed to calculate Z in order to test the hypothesis. So that basically means they took all their numbers, they ran the numbers, they crunched them all together, and they got a test statistic of 1.42. And so we can use that to determine whether that's significant enough or whether it's not significant enough to claim that there's some sort of effect. And here's the effect that they're trying to claim, that the proportion is greater than half, greater than 0.5. So we call that a right-tailed test because of the greater than sign. That we would reject our null hypothesis and claim that some sort of statistically evident effect is happening if our test statistic lands over here in this rejection region. So the first part, identify the hypothesis test as being two-tailed, left-tailed, or right-tailed. This is a right-tailed test because they're testing this claim that p is greater than 0.5. So finding the p-value. Let me pull up what do we use? Not StatCrunch, that's an old one. StatDisk. Let me pull up StatDisk. To find the p-values, you could use these tables. That's kind of an old school way of doing things. A quicker way is to go to statdisk.com, that free website we've referenced in this course. Click Analysis, Probability Distributions, and we're talking about z-scores. We're talking about that bell-shaped curve. So we're looking at a normal distribution. The z-value we got was 1.42, and then cumulative, we just need to hit 1. If you click Evaluate, that tells you the area to the left, area to the right, everything we need. So this is the key one, okay? Because we said this is a right-tailed test, so we just want the right-tailed value. The p-value for this test is 0.0778, okay? Because that's the right-tailed area. That's how much area is over here, 0.0778. So like 7.78%, okay? And if we have a rejection significance level of 0.01, our p-value isn't low enough to reject the null hypothesis. The p-value is like the chance that our null hypothesis is true. There's like a 7.78% chance that there's no effect going on. Okay, it's pretty low, which seems to imply that something is happening here and the researcher's claim is true, but it's not low enough to reject the null hypothesis according to their stated significance level. They want to be extra sure. They want it to be less than a 1% chance that they're wrong in their assumption. So should we reject HO? We should fail to reject HO. Fail to reject HO because our p-value is not low. There's kind of like a little phrase that's often mentioned in statistics classes. When the p-value is low, reject HO. Okay? When the p-value is low, that means you've got evidence to reject HO in favor of your alternative hypothesis.